Hi, my name is Akila Tate, and this is my lab for oscillations. So the purpose of this lab was to investigate the motion of a spring mass system with the mass oscillating in an arc. The goal was to determine whether the model follows the energy principle, and some fundamental physics principles that I used were Newton's second law and the energy principle, and the main result of the lab was that the system's total energy remains constant at zero, thus demonstrating the energy principle. So for my observed motion experiment, I used tracker software to track the observed position of the spring mass system. And here are some of my initial conditions, and this is the graph that the tracker software produced. But there were also initial conditions that I had to find. And so here you can see I solved for t, which is the period of the graph, and I solved for K, which is the spring stiffness, and then I solved for the relaxed length as well using the spring force equation. So after that, I made my computational model using GlowScript, and the model predicts and graphs the spring mass system's motion and energy changes. And here are my initial conditions that I entered into GlowScript. And then next I have the length and system energy, which I entered into GlowScript. And then we have the prediction loop, which you can see some of my formulas from my introduction slide are included in the code. We have the position update formula as well as the spring force formula. And yes. Now, when we compare the computational versus the observed model, I place them together on one graph, and this is the x position versus time, and this is the y position versus time. So as we can see by looking at the graph, we have some similarities and differences. The models overlap in the beginning, showing that they are very similar for a short period of time. However, as time increases, the graphs differ more and more. And that could be because of some possible errors. One, the computational model doesn't account for the fact that in reality the system isn't isolated, therefore there will be work done from the surroundings. And also, there could be an inaccurate center of mass placement on tracker done by my part. So was the energy principle satisfied? Yes, the energy principle was satisfied. As we can see in this graph, it has the different types of energies that were within the system, and since no external forces affected the isolated system, the change in energy was zero. And even though different types of energy are shown in the system, this graph here shows that the total change in energy is constantly zero. So if we compare oscillation periods, we see in the x direction, we have a period of 1.646 seconds, which gives us a K value of 5.858, whereas in the y direction, we have a period of 1.5197 seconds, which gives us a K value of 6.872. So choosing different directions produces deviations in the period, which ultimately affects the spring constant and the graphs. So in conclusion, the model did follow the energy principle, and the change in energy in the system remained constant at zero. And that's all. Thank you.